All right, good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up 97's on the screen as soon as you log in. You do need a calculator. It's a sketch a box plot and make a bell curve with that data. I'll give you guys some time. Copy and go. All right, box plot. Let me get my number line over here. So a minimum of 2, maximum of 47. But now I need my Q1, Q2, Q3. All right, check with the neighbors, see what they got for Q1, Q2, and Q3. Q1, Q2, Q3. All right, let's go with, how about in the back? How about, Santi, what'd you get? Q1. 15. Q2. 283, Michael Jordan. And Q3. 30, looks about right. Hands if you got something like that. Yeah, we got it. Our bell curve. We need a mean and we need a standard deviation. Check with your neighbor and Santi's going to pass someone. A mean and a standard deviation. All right, Santi, pass someone. Mel, mean. $23.3, that looks about right. We need a standard deviation. Pass them one. What is it? 15.03? Okay. 0.03. Hands if you got something like that. All right. So, if we go one standard deviation up, we should be at 38.33. One standard deviation down, we should be at 8.27. No calculators needed. I'm going to make a shirt, Q merch, right? No calculators needed. I mean, you'll buy it, right? $10? I mean, they're selling tamales at the fair for what? $10? One tamal? What? Let me repeat that again. One tamal, and it's recording. One tamal for $10? Does it have gold sprinkles? Is it made out of unicorn instead of pork or beef? Oh my goodness. Anyway, send that in, please. Did I send you the screen already? Yeah, right? All right. Copy the agenda, please. And lemonade's $15? It's good? Yeah, what is it, 30 ounces? Oh, really? Oh, okay. Then if it's like a 64 ounce, then I'll understand that. Oh, really? Oh, okay. I thought it was $5 refills. Yeah. I guess. How about the corn dogs? Do you have the jumbo corn dogs? Are they selling the jumbo corn dogs there? No? Yeah? Let's go. Maybe this will be the year we go and get a corn dog or something. Just gonna have a corn dog? Yes, $20. They're starting to compete with Disneyland. Oh yeah. I remember when I went to grad night, the Galaxy Burger was $20 back then. I don't know how much it is now, but it's like, there was a Galaxy Burger, yeah. Anyways. But it was good though. It was after all the walking. Anyways, warm-up 97 done. Today we're moving on to combining probability and counting rules. Today we're going to mesh different rules together since you love probability. And your home plate for tonight is on 4.5. You're going to go at the end of that section in your textbook. Go to exercises 1 through 10 odds. Okay? All right. The code for this presentation is EK3XH. 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 The agenda is on your screen. All right, and by now, since yesterday we had plenty of time to redo or retake pop partes, submit videos that you were missing and stuff like that. Once again, we're closing the quarter pretty quick, so you guys need to really pick up the pace, some of y'all. So, please, pretty please, with a cherry on top. All right, so with that said, I can identify and compute the basic probability. Get a Cornell note ready, please. I can identify and compute the basic probability. And as I was mentioning today, we're combining a bunch of rules together today. However, here goes the road as to where we've been. Here goes the road book. We talked about probability being the chance of an event occurring. We talked about different probability, classical, empirical, and subjective. Is that correct? So before we move on, remind your neighbor of what's the difference between classical, empirical, and subjective. See if they remember. What is the difference between classical, empirical, and subjective? What is the difference from one to the other? Then Aaron's going to enlighten us since he's really focused in the session. Woo-wee. Very good. And what if right now I ask you for a notebook so I can check and you guys get your 25% of your overall grade done and over with, right? Right? Everybody ready? Yeah? All right. Cole, you ready for the check? Yeah? Okay, good. Because I have your notebook over here, so I don't know. Oh, okay. All right. Who's going to enlighten us? Aaron, what's the difference between classical and empirical?
Classical is set.
Uh-huh.
Empirical is like cancer.
All right, so classical is already set. You set up a table. It's already, done. Empirical, you have to set up a table and get frequencies by going through the experience, okay? How about subjective? Random data, but depending on what? Subjective. On the what? On the person observing the event. Kind of like each one of us has different perspective, right? So therefore that's subjective. Okay, good. From there we went to the formulas for the first two, classical. There it is, P of E over N of E. P of E equals N of E over N of S. Yes. Then empirical, P of E equals frequency over N. So far so good, yes? Okay, good thing you guys are paying attention because we're going to be using these. Here goes the other rules. And remember these, yes? And then these, your favorite. And then these, your other favorite. And then this one, your other favorite. And then from there we went to the counting. And we focused on permutation and combination. Yeah? All right, so today we're going to be doing a combination of all of those in one. But just to make it easy, bring down the stress level, we're only going to focus on classical using this formula and using counting rules for permutation and combination. Only these three. Is that all right? All right, so with that said, copy this next column on your notes, please, so you can have an example of it. Write example number 2, and it reads, a store has 6 TV graphic magazines and 8 Newstime magazines on the counter. If 2 customers purchase a magazine, find the probability that one of each magazine was purchased. So copy that onto your notes. I'll give you some time. Go. All right, here we go. A store has 6 TV graphic magazines and 8 TV magazines, Newstime magazines. So if you notice, this one has a combination of 2 types. TV graphic magazine and Newstime magazine, okay? However, I said to get started, we're going to be using a combination of two formulas. So without looking at your notes, tell your neighbor the classical probability formula. P of E equals what? P of E equals what? Remind your neighbor. P of E equals all right, looks like Mario's got it since he's not on his phone or anything like that. Very good. David got it. I see you, David. And I just showed you guys the formula. Really? Wow. Carter's got it. Very good, Carter. So let's go with, we haven't we called on in a while, Carter? Brandon Doherty. P of E equals N of E over N of S. That is correct. Let's go. All right. That is correct. So we're going to use this to set up our probability for this, but notice here now we have two different things happening in this problem. So let's continue. So instead of P of E, think about it. What would I write? Think about it first. What would I write? All right, talk it over your neighbor. What would I write to get started? Instead of P of E, what do I write? Brandon, pass someone. Cole, what would I write? Instead of P of E, I would write what? P of help him out, Mia. Yeah, P of TV and what else, everyone? And T for news time. Yes? All right. Now let's think. Watch, I'm gonna trigger your noodle. If it's an and, what would we do with that data up here? Talk over your neighbor. What would you do with that data if it's an and? Ooh, multiply. That is correct. So put a big dot right there. All right, so let's start with TV. And in this regard, the problem says, if two customers purchase a magazine, find the probability that one of each magazine was purchased. Now, question, does the order matter or how they buy the magazine? No. So with that said, what would I write for TV graphic? Talk it over your neighbor. What would I write for TV graphic? What would I write for TV graphic if the order did not matter? All right. Looks like Aaron's got this. All right, Aaron, let me help you out. What would I write? 6 and? One. That is correct. One magazine of the graphic TV. So if that's true for that, now we need to write something for the news time. Tell your neighbor what you would write for news time. What would we write for news time? Aaron, pass someone? David, what would you write? 8 and 1. That is correct. David in the house. That is correct. However, what does the denominator of our classical formula say? Total of totals. Is that correct? So, tell your neighbor, what would we write here for the whole thing? Think about it. What would we write there for the whole thing? Man, I can feel your brain thinking outside of yourself. All right, David, pass them one. Cool. Santi. Total of totals. Let's see, help them out. Looks like Z's got this. What do you think, Z? Yes, you do. Total of totals. Total of totals. 14. And 2 is correct. That is correct. Let's go. We got this. So, basically, so now we just need to do our computation. We need a number, a magic number for that, a magic number for that, and a final number for that in order for us to find our probability. So, remind us of the formula for combination. Let's see, combination formula. Looks like Austin. C of?
C of 6.
No. Just give us a formula first.
C of n, and then r equals n factorial over n minus r in parentheses factorial times r factorial.
That is correct. So you're going to follow this for each of these. Let me write them out right here. So we need C, 6 and 1. We need a combination of 8 and 1. And we need a combination of 14 and 2. So I'll give you guys a head start. There's your formula. Fill in the gap. Give me those numbers, please. Give you a head start. Go. 1. Tell me what to write. 6 factorial over 6 minus 1 factorial and 1 factorial. All right, so that becomes 6 factorial over 5 factorial, 1 factorial. So therefore this is 6 times 5 factorial over 5 factorial, 1 factorial. So this is 6. Hands, we got 6? That is correct. Ooh, pass that one for the blue one. Max, help me set up the blue one. Yes, so we got 8 factorial over 7 factorial, 1 factorial. 8 times 7 factorial over 7 factorial, 1 factorial. So this is 8. Hands if you got 8. All right. And the last one, passing one, Max. Cool. Alessandra, help us set this one up. What do I write? Uh-huh. Yes. Yeah, so we got 14 factorial over 12 factorial, 2 factorial. So this is 14 times 13 times 12 factorial over 12 factorial, 2 factorial, which is 14 times 13. What is it? 182. 182 divided by 2 times 1 is 2. So this is 91. And if you got 91? All right. Therefore, the probability of 2 customers purchasing a magazine is 48 over 91. From 1 to 5, how come to borrow you with that? Yeah, it's just a setup, right? Just takes the time to do the setup. All right, send me your notes, please. Let me send you the screen. Hold on. There it is. All right. Next. Example number 2. Look up, please. The California Powerball jackpot is at 645 million. That's not true anymore. I think it's at 300 million right now. But it was at 645 million at one time. So anyways, what are the odds of you winning the jackpot with just one ticket? So we'll just change the amount. Like right now, I think, like I said, it's 300 million, the jackpot. Think about what would you do with 300 million? Actually, the state takes away 1/3 of it, so instead of 300, you get 200. But it's still a lot, right? So, for those of you that don't know how to work this, let me zoom in. Here it goes. So these tickets, you find them at convenience stores, and they got several parts. They have parts A, B, C, D, and E. I'm just going to focus right now on E. To play, you need to fill this out. It's got 2 parts. The first part is here, and it says what? Select what? 5. So you need to select 5 out of how many? 69. Okay, so you select 5 out of all those. That's part 1. Okay? Now, does the order matter? No, you can start from over here and then go back over here and da-da-da-da-da and so on and so forth. Okay? However, the second part, you need to fill out this part, and it says select what? 1 out of how many? 26. So this one, you do need to, like, since it's only one number, you need to be specific, right? So order does matter. So think about that one. The top portion, order didn't matter. Order does matter. Okay? Does everybody see how it works now? So select 5 and select 1. So, with that said, let me zoom out. On your paper, write example number 1. You're going to write select 5. And then the second part, select 1. Since this is a 2-part problem, what do we do with those numbers once we find them, everyone? Yeah, we multiply them, right? So, once again, telling you what we would write for the first part, since order did not matter. And what would we write for the second part, being that the order matters, that it's one specific problem? What would we write? Talk to the neighbor. What would we write? Then we're going to have Amelia. Oh, no. Alessandra went last. You're going to pass to someone. All right. All right, Alessandra, pass someone. For the first part, Amelia, what would I write? Combination of what? 69 and 5. That is correct. Pass someone for the second part. What would we write for the second part? Logan. 20. 26? And that is correct. Let's go. So, find me the combination of 69 and the R of 5. And then find me the permutation of 26 and 1. Then at the end, we're going to multiply whatever we get for the C times whatever we get for the permutation. Giving you a heads up, it's big numbers. I'm just trying to bring some enlightenment to you guys, especially some of you that you have your parents playing the lotto and just losing a lot of money doing that. You guys can let them know. All right, Logan, pass someone so they can help us set this up. Brandon Doherty, tell me what you write. Uh-huh. So this is 69 factorial over 64 factorial, 5 factorial, and then 69 times but we still have the 5 factorial, yeah? So therefore, what is this big number? 69 times 68 times 67 times 66 times 65? 1348, 62, 1560, divided by 5 factorial, which is 120. What is it? 23, 85, 9.7, 0.7. Okay, I'm going to write that over here. That 112 million, 385,179.7. So we got our combination done. No? What'd you get? $513, like that. Hands if you got something like that. All right, yeah. So, come on, Vianney. There you go. All right, so we got 11,238,513. We're going to multiply times whatever Cole got for 26 permutation 1. All right, Cole. All right, tell me how to set it up since you haven't done it. Help them out, Mia. 26 factorial over 26 minus 1 factorial. So we got 26 factorial over 25 factorial which is 26 times 25 factorial, or 25 factorial, so the answer is 26. All right, so after all that, what are the odds of you winning the jackpot with one ticket? The probability was what? What is 11,238,513 times 26? Who's got that magic number? Aaron, go. What is it? Just give me numbers from the beginning. 2, 9, 2, 2, 0, 1, 3, 0, 3, 8. Like that? Like that? Yes, that actually is correct. The probability of you getting or hitting the lotto, the Powerball, is 201,338 to 1. To one of you. So, if people keep going to give their money over there, they're going to keep losing because look at those odds. Well, somebody said in my previous period, they're like, Mr. Q, but there's a possibility. one out of all of those. Wow. Anyway, send me your notes, please. I want to see what you wrote. Yeah, it's just a lot of computation, guys, when we get to the combination of different rules and formulas. So, anyways, from 1 to 5, how comfortable are you combining stuff? Oh, it's not? Okay, my bad. Yeah, 5 fours, 5 fours. Okay, there it is. All right. So for those that are following along on YouTube, make sure you get some practice in. And I'm going to stop the video right there. See you guys next time. Don't go buying lotto tickets. Bye. My bad. They said that you guys still have a chance. So, whatever. Or go buy a tamal for $10.